In the last presentation, we completed positive and negative logic. In this lecture, we are going to cover positive and negative logic AND gate, positive and negative logic OR gate, what is dual form, and finally we will derive rules to write dual form. So we will start with positive and negative logic AND gate. I will take a 2-input AND gate. Let's say A, B are the two inputs, and the output of this 2-input AND gate is Y. And you already know, in case of AND operator, the output will be high when both the inputs are high, and if any of the input is low, the output is going to be low. So we have 4 possible combinations because we have 2 inputs, and the first combination is low, low, when both the inputs are low. Then we have low, high, high, low, and finally we have high, high. So these are the 4 possible combinations, and the output will be low, 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 and high. So this is the simple AND gate. Now we have to find out positive logic AND gate and negative logic AND gate. You have to remember what is positive logic and what is negative logic from the last presentation. It is very simple. We have to only convert this low to 0 and this high to 1 in case of positive logic, and low to 1 and high to 0 in case of negative logic, because this is what we mean by positive and negative logic. In case of positive logic, the higher value corresponds to 1. 1 is the representation, or you may call it symbol, and the lower value corresponds to 0. This is for positive logic, and if you reverse this thing, higher value corresponds to 0 and lower value corresponds to 1, we call it negative logic. So this is all we have to do to find out positive logic and negative logic AND gate. So let's do it. First of all, I will find out positive logic AND gate. So positive logic AND gate, A, B are the two inputs, Y is our output, and now we will fill this table depending upon the convention of positive logic. Low is 0 in positive logic, so we have 0, 0, the output is 0, 0, 1, because high is 1 in positive logic, output is 0, 1, 0, 0, 1, 1, 1. So this is the simple AND gate in positive logic, and we are going to use this table throughout this course. Now we will find out the negative logic AND gate. The negative logic AND gate. We have two inputs, A, B, Y is the output, and in case of negative logic, the lower value is represented by 1. So we have 1, 1, 1, 1, 0. The higher value is represented by 0. So we have 0, and we have 1, then 0, 1, 1, and finally we have 0, 0, 0. So this is the truth table for negative logic AND gate. Now we will move to positive and negative logic OR gate. We are going to follow the same steps. I will do it quickly, and we will take 2-input OR gate again. A, B are the two inputs to our OR gate. We have low, 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 high, high, low, high, high, and you already know, in case of OR operator, the output will be high if any of the input is high. So in first case, we have the two inputs as low, low, so output is going to be low. Then we have B as high, so output is high. A is high in the third case, so output will be high. And in the fourth case, both the inputs are high, so output is going to be high. So this is the table for OR gate, and we want the positive logic OR gate. So we are going to convert this to the positive logic OR gate. The way we converted this table to the positive logic AND gate. So we will follow the same steps, and I'm going to represent low by 0 and high by 1. So we have 0 0 0 0 1 1, then we have 1 0 1 1 1 1. So this is positive logic OR gate, and we will have our negative logic OR gate A B Y. Low is represented by 1, so 1 1 1 1 0 0 0 1 0 0 0 0. So this is positive logic OR gate. Now we have 4 tables and we are going to compare them. If I compare positive logic AND gate table with the negative logic OR gate table, I'll find they are same. Let me copy this down. I will copy and then paste it, and I will drag it near to our positive logic AND gate table, and we can see that it is same. When A and B are 1, the output is going to be 1. You can see. In the same way, when both of them are 0, output is 0. And for the rest 2 cases, we will find that we have output is equal to 0. So these 2 tables are same. So I can say that positive logic AND gate is equal to, this one is for negative logic OR gate. You can see this is for negative logic OR gate. So I can say that positive logic AND gate is equal to negative logic OR gate. In the same way, if I compare negative logic AND gate with the positive logic OR gate, I will find they are also same. So we have 2 things. Negative logic AND gate is similar to positive logic OR gate. So these points are very, very important. You have to keep this thing in your mind, that positive logic AND gate is equal to negative logic OR gate, and negative logic AND gate is equal to positive logic OR gate. Now the question comes, what is dual form? The dual expression is used to convert the positive logic to negative logic and negative logic to positive logic. Very simple. So if I say I have an expression like A and B, and you want to find out the dual form, so let's say this is the positive logic, and as I have told you, the dual form or the dual expression is used to convert the positive logic to negative logic. So if you want to find out the dual of this expression, you have to convert this to the negative logic. So the negative logic of this thing is A or B. So you have to replace this AND operator with OR operator, and the reverse is also true. If you have A or B and you want to find out the dual, then you have to make it A and B. So this is the only thing that you have to do in case of dual form. If you remember the complement, in that case also we replaced OR operator with AND 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 operator with OR, but we also complemented the variables. In this case, in case of dual, we don't have to complement the variables. We have to keep the variables as it is. If I have A, then after taking the dual form, I have A, not A complement. In the same way, B is B, not B complement. So this is the only difference between the dual and complement form. We don't have to take the complement of the variables in this case, and I have already explained you how the positive logic AND gate is equal to negative logic OR gate, and vice versa is also true. So this is all for this presentation. In the next presentation, we will continue this dual form, and we will solve few examples, and we'll see what is self-dual. Some expressions are self-dual. If you take the dual of that expression, you will find the same expression. And if you have any doubt regarding this topic, you may ask in the comment section.